Okay, welcome to the lecture number 60. So, we have been discussing about the control moment gyros. So, I have made this figure for the control moment gyro in advance. So, what we can see here that the satellite is enclosing this control moment gyros, and we are assuming that the center of mass of the satellite main body and center of mass of the control moment gyro both are coinciding. So, center of mass of the satellite and CMG are coinciding, satellite main body. Satellite main body and CMG are coinciding, and therefore, the equation then becomes very easy to work with, because if you remember that whenever we are differentiating this. So, we have got the term like if we have written m, the equation for the external moment. So, that has appeared at dH by dt with respect to the E frame and plus V cross P. Okay. So, V 0 plus V 0 cross P, where P is the total linear momentum of the whole body. So, unnecessarily this term we do not have to carry if we assume this. Okay. So, this will simplify little bit our the whole process of working with this, and it is always possible that you fix your the other components such that the center of mass and the satellite, the rest of the satellite center of mass, both of them coincide. So, this we are terming as B, and this is your CMG. So, here in this figure C 1, C 2, C 3 as it is written here, this is attached to the satellite body, but not rotating with respect to the satellite. Okay. So, it is a fixed in the satellite, and there is also the body axis which I have not shown here, and say that body axis if I try to show here. So, that I can point out here along this direction. Let us say that these are the three directions in which your this is your E1 direction body, E2 direction of body and E3 direction of body, the small E1, E2, E3. Capital E always we have used for the inertial frame. Okay. So, in this body then your C1, C2 and C3 they are fixed. So, here is your C1, this is C2 and C3. These are the fixed direction, they are not going to change. Thereafter, we have chosen a frame which is attached to the frame external frame D, okay, which I have shown as D1, okay, D2 which is going here, D1, D2 and D3. This is rotating along with the frame D, but there is one point to note, D3 and C3 they are always along the same direction. Okay. So, this D3 and C3 which is written here, shown here. Okay. So, they are always along the same direction, because this frame, the frame shown by blue which is the D frame, it is rotating about this axis. Okay. It is rotating like this. So, this is rotating in anti-clockwise direction, anti-clockwise. So, these two are not going to they are always in the same direction. So, this way we have defined D 1, D 2, D 3. So, your D 1 and D 2 will change their direction as the angle psi changes. If this frame it rotates and comes to this place, new place, which I have shown you earlier also, this is the old place and this rotates by here this psi angle. So, this you are showing as psi dot. Okay. So, if it comes to this place, you will see that this will change its position and this will also change its position with respect to the satellite body. Okay. Thereafter, we have fixed one frame to the inner ring, this is your inner ring. So, to this the frame we have fixed such that your along this direction you have f 1, f 1 is coming here, this is your f 1. Okay. So, from this place f 1 is being shown, from this place then outward this is your f 2 which is shown here. So, f 2 is here, f 2 cap, and similarly in the upward direction then is your f 3 is shown. Okay. So, this frame is rotating along with the pink frame which is here f frame. Okay. Now, we can start. So, all the things I have written here, f 1 f 2 is attached to the frame f, d 1 d 3 is attached to frame d. Okay, and C 1 C 2 C 3 it is attached to the satellite body and it is a non rotating frame. It will rotate only along with the satellite, but not with respect to the satellite, this frame. Okay. Okay, so, next we can start composing our problem. So, we will write as omega angular velocity of the main body, which is your b, this part, okay. Angular velocity of the movement body with respect to the inertial frame, and this we will write as simply as omega. Then angular velocity of the d frame with respect to the b frame okay, because your this is the frame here and this frame is rotating by here psi dot. So, only and this direction is C 3 cap. So, only this part will appear here. Okay. So, d with respect to b frame. Okay. Thereafter, the angular velocity of the f frame with respect to the d frame, that will be theta dot times d 2 cap, which I have shown here. Okay. Theta dot here is in this direction, this vector goes here in this direction multiplied by the corresponding unit vector. So, I am not using this notation E d cap and something like that, because again we have to carry so many subscript and other things. So, this is easier to comprehend here in this place, and thereafter the lastly we have the angular velocity of the wheel with respect to the which frame. This is rotating with respect to the f frame. Okay. This is attached to the f frame, axle of the wheel it is attached to the f frame. Okay. Therefore, this we can write as capital omega. So, capital omega we have written for phi dot, which is the spin rate of the wheel. So, capital omega times f 1 cap. Now, f 1 cap will change direction, d 2 cap will change direction with respect to the satellite, all of them are changing. Okay. So, with respect to the satellite f 1 will change, and also this changes with respect to the d frame and so on. So, this procedure we have to carry out. Okay. Now, here the total angular momentum, it can be written as the summation of the main body frame and the main body, and then the outer frame which we have noted as d, and then the outer frame we have written as d, and then the f frame, okay, and then the angular momentum of the wheel. Okay. So, this approach that we are taking here, this is showing you these are the absolute angular momentum, okay, not a relative one. Just as in the previous lecture we have done that, and then we have combined to get a derivation which was in the sense relative sense with respect to the satellite. Here all these are the absolute angular momentum. Okay. So, we are making free body diagram of each and every one. This is your satellite, this is your outer frame, then this is your inner frame, and to this attached is the wheel. Okay. So, all of them are the free body diagram FBD. So, for all of them we are writing here like this. Now, we have to compose each of the term here. So, the first term H b, this will be equal to moment of inertia of the B frame. B frame means it is the main satellite body, okay, which excludes the CMG. Okay. So, I b times omega b slash e, this is the angular momentum of this, and this we are writing as I b times, for convenience this we will just write as I b times omega. Thereafter, we need to also, so your H dot then will be written as H dot equal to H b dot plus H d dot, and all of them with respect to E frame. Okay. H dot okay. So, you can see that we have written all of them with respect to, means we are considering the free body diagram. So, therefore, H dot b slash e, this quantity will be written as I b times omega. So, there is a frame fixed into this, which we are writing as the E 1, E 2 and E 3. This is your body frame attached to the main body, this B. Okay. So, in this body frame, the moment of inertia of this main body is not going to change, and therefore, we can write it like this times omega cross I b times omega. I am not putting here dot just to unnecessarily, this I am considering that this part will give you a vector and this is multiplied by a vector. So, it is a very simple, okay. Unnecessarily complicating in terms of the dyadic, it will not benefit here in this place. So, it is a follow up, this omega cross here, omega cross what we have written omega cross, this is simply implies this is nothing but omega tilde cross, okay, which is a matrix. And this omega here, this omega, this implies that this is nothing but identical to omega tilde, equivalent to omega tilde. Okay. So, this way your equation then gets simplified. So, this is your equation number, let us say A. Now, we take the next one, which is H d. H d, now this is your D frame. So, D frame to this we have attached one frame, which is D 1, D 2 and D 3, and this frame will be rotating with respect to the satellite. So, in the D frame, the moment of inertia, because it is fixed to the outer frame and it is rotating along with the outer frame. Okay. Therefore, moment of inertia of this frame in D 1, D 2, D 3, it is not going to change, and it makes us easier to write. So, I can write it like I d times omega d cross E. Here see the difference, this is d cross B, d, this is B, okay. This is with respect to B. Okay. Here I am writing omega d slash E, means this angular velocity of the frame D with respect to frame E, which is an inertial frame. Okay. So, this can be written as I d, then the angular velocity of the main body, and this is because it is embedded in this main body. So, we can write this as psi dot. So, or we can write as omega times omega d with respect to the B frame. Okay. So, this will be equal to this summation is equal to this part. Which will write as omega times psi dot C 3 cap. because psi dot is lying along the C 3 cap direction. C 3 cap and D 3 cap, they are along the same direction all the time, C 3 cap and D 3 cap, and therefore, D 3 cap can be replaced by this, and it makes easier, some of the steps can be skipped. Now, we can write here H dot. So, H d dot, then it becomes d h d by d t with respect to E frame, okay. And this we can then expand as d h d by d t with respect to the D frame and plus omega d d slash c cross. Remember the past derivation we have done, omega this is I d times omega d slash c. This is nothing but your the H d term. Okay. So, this term is your H d. So, this is the way we have written it. You have to particularly take care of the terms while I am writing here, this is omega d slash c. Okay. If we look here in this place, this was omega. Okay. So, this is the difference here which we have to take care of, because with this is now frame you are considering, this frame here, this particular frame, okay, and this is you are considering with respect to the E frame. Each of them you have made as a free body diagram, and then you are considering. So, in that case, this is the way you will write. Okay. Now, H d is given to be this quantity. Okay. So, we can expand it in the next step. So, we have H dot d d h d by d t. So, this is the quantity H d we have to insert there with respect to the D frame, and this is omega plus psi dot times C 3 cap, and then I d is also there. So, I d we have to put the I d is there. And this plus omega d I d times omega d slash c. Okay. Now, this part we will expand. So, in the D frame I d does not change. So, I d will simply come out, omega gets differentiated, and this is with respect to. So, your d omega by d t, while you are writing here this subscript d, but this is identically equal to, this is what we have done earlier also. This is with respect to basically E frame. Okay. While we differentiate the angular velocity, so this goes with the E frame. So, this way if we write it here in this place. So, I d times omega dot and then plus psi double dot, okay, then C 3 cap and then psi dot and this C 3 what this C3, how it is going to change? D by dt with respect to the D frame, and here is your C3 cap. So, C3 cap is a vector which is fixed in the body. Okay. This is your C3 cap vector, and this body itself, this is rotating at the rate omega. Okay. Therefore, we will write here this is omega times C3 cap. So, this is the expansion of this term, okay. And rest we can copy like this. So, this is your equation number B. Okay. And I d is common to all of them. So, I d we can keep it outside here. Okay. In the next step, then we have to take the F frame. So, H dot F, and this we have to do with respect to H dot F with respect to the E frame. Okay. So, H f now we have to pick up. H f is your this frame, the horizontal one, which is the inner frame, this is the F frame. Okay. So, this will be I f times the corresponding moment of inertia. So, omega f with respect to E, moment of inertia I f, and then omega f slash E means the velocity absolute angular velocity of the frame f with okay, which we are writing with respect to frame E. Now, this f I f we are writing, this is defined in the f frame itself. Okay. So, f frame we have shown previously, this is your f frame. So, along the f 1, f 2 and f 3 vector it is defined. Okay. So, as this f frame rotates, so f 1, f 2, f 3 will rotate, and therefore, in the f frame the corresponding moment of inertia I f does not change. Okay. So, this you have to do with respect to E frame. And then we write this as I f times d by dt, okay, with respect to the f frame omega f slash E, okay, and plus omega f slash E cross okay. This term we need to expand, this is as usual. Okay. So, this become I f times now d by dt, and remember while I am writing here I d. So, this is defined in the D frame itself, this is defined in the F frame itself, here this is defined in the F frame itself. Putting so many subscript, it makes the things complicated. Okay. Understanding the control moment gyros complete function, it is not impossible or very difficult, but we have to take care of all the subscript and other things. Okay, and rest we have to write for omega f e. So, omega f e will be consisting of omega, first omega is the angular velocity of the main body, then the D frame is rotating with respect to the main body. So, therefore, for this we have to keep it here, okay. And thereafter your F frame is rotating with respect to the D frame. Okay. So, that is given by theta dot times, and in the corresponding D frame the corresponding unit vector is theta dot times d 2 cap. Okay. So, theta dot times d 2 cap. Okay, so, what this quantity is? This is your omega psi dot E we have written as d cross b omega d slash b, and then thereafter f with respect to d. So, this is omega d slash b. This is omega d slash b, and this part is omega this for the d frame with respect to the b frame, or with this is okay. This is with respect to the b frame, and the lastly we have used the notation theta dot d here. This is f frame with respect to the d frame. So, this is the omega f frame with respect to the d frame. So, these three are added to get this omega f slash c. Now, we expand this. This quantity will be simply omega dot, this quantity will be psi double dot, and then C 3. As earlier, how this is changing, that we have to write here. Okay. So, that becomes psi double dot C 3 cap and plus this will change because of the rotation of the D frame. Sorry, this is fixed in the C 3 frame. What I am stating that this is your D frame and this is along the C 3 cap direction, psi dot is along the C 3 cap direction. So, this is because of the rotation of the main body, your this quantity C 3 cap will change as we have done earlier. So, therefore, we write here psi dot times omega cross C 3 cap. And then we go to the next term. So, this is theta double dot d 2 cap, and how the theta dot is going to, this d 2 vector is going to change. So, theta dot cross theta dot times now this theta 2 dot times d 2 cap. This is a vector which is d 2 cap is a vector which is fixed in the this pink frame, fixed in the blue frame, and it is a pointing here in this direction. So, the question is how we are going to change this part. So, omega times C 3 cap and then theta double dot is coming here, H f we are taking here. Okay. Next part we have to write here the proper cross d 2 cap, and then this bracket will be closed, and thereafter this part omega f slash c cross I this f f omega f slash c. So, this part we are keeping as it is and the other part we are expanding. Okay. So, the question is how your d 2 vector is changing. So, d 2 vector will change and already the psi vector we have taken care of. Psi vector is changing because of the omega only, okay. And d 2 vector will change because of omega and plus psi, okay, because d 2 is here in this place. So, this body is rotating at omega and also together with this frame is rotating at the psi dot to which your d 2 vector is attached, okay, to the d frame, and d frame is rotating at psi dot. So, we have to take care of these two factors. So, this is omega plus psi dot times c 3 cap. This is the angular velocity of the frame, the outer frame. Okay. So, the outer frame angular velocity. So, this part is nothing but your here this part is ending, this part is nothing but your omega frame d with respect to frame E. Here this is not a cross product, here just we have written it like this. This is theta dot times omega. So, omega is the main body angular rate and d frame is rotating. So, that we are adding. So, d slash c this becomes. So, omega dot d slash c, perhaps we have used for some other notation. Now, d slash b we have written here, what d slash e we have written. Okay. So, if you add these two, so your omega b slash e plus omega d slash b, okay, that gives you the total omega d with respect to the E frame, omega of d with respect to the E frame. So, this part I am not writing here, this is obvious. Okay, and we can expand it and write it. So, this constitutes your the angular the equation for the f 1, the frame f, and thereafter we have to write the equation for the wheel. So, you can see that how much complication is arising. If you take the exact equation for the CMG, control moment gyros, and that too we are assuming that the center of mass of the control moment gyros and rest of the satellite it is a coinciding. If you do not assume that, then the system will be equation will be further complicated. Okay, so, we can wind up here, we can write as H f slash c, H dot f slash c, this we have written as H dot f, this part and then the other part. Okay. So, I f psi double dot C 3 cap just rearranging the terms, theta dot times d 2 cap, this is this part, so this part lastly I am writing omega cross, this is omega cross psi dot times C 3 cap and plus I f f and times this cross so this is your equation number C. This we could have, this term we could have written before this, that is okay, that is fine, it does not matter. Similarly, we write for the will equation can be written. Okay. So, in that case H will we are writing and that we are writing in the will frame itself. Okay. So, will is attached to the frame F, which is a rotating frame. Okay. Omega will of with respect to E, this is the basic equation. And omega will we can write as angular velocity of the will with respect to the F frame plus angular velocity of the F frame with respect to the D frame and then angular velocity of the D frame with respect to the B frame. We are not writing with respect to the C frame, because C is also fixed in the body and B is also fixed in the body. So, it is just a matter of orientation, okay, it is not rotating. And this can be expanded as I w omega d omega d slash b, and one more term is there omega b slash c. So, this is the rotation rate of the angular velocity of the body with respect to the E frame, then with respect to the B frame the outer frame angular velocity, with respect to the outer frame inner frame angular velocity, and with respect to the inner frame will angular velocity. So, these are the 4 terms which are appearing here in this place. So, we can write this part is simply your omega dot as per our earlier notation, omega d slash b, this we have written as omega d slash b psi dot C 3 cap. So, this is psi dot C 3 cap and omega f slash d, this is theta dot times d 2 cap, and this capital omega, this is nothing but capital omega is along the one direction of the frame F. So, this is capital omega times f 1 cap. Okay. Now, we need to differentiate this part again, this is not omega dot, this is just omega dot will come in the next step, and here this capital omega which we have replaced phi dot by capital omega. You can keep phi dot as well, it does not matter. Okay. So, the next step involves getting the dot of this, means we have to differentiate this d h by dt, write it in this format with respect to the E frame, with respect to the inertial frame, how it is changing. Okay. So, that we can do it on the next page. So, I will write here h will, this is the absolute angular velocity of the will equal to I w, okay, and I will, this is defined in the F frame. So, instead of writing I w like this, I can, this is equivalent to writing I w in the F, because in the F frame the direction of the axle of the wheel it is not changing, okay, or neither the moment of inertia of the wheel is changing in the F frame, okay, which is the inner frame. In the inner frame is like this, okay, it is coming like this. Okay. So, along this direction we have kept as F 1, here as F 2 cap, and F 3 cap is going vertically out, okay, out of the wheel. So, this is the rim of the wheel. Okay. So, therefore, in this D frame, sorry, the F frame, which is the inner frame, the wheel moment of inertia will not be changing. So, we will describe this I w, you can write as I w w, or either you can write with respect to F. So, both are same. So, we will put a tag later on, let us start with, and then we have the other terms, we will just reverse all the terms from, we will start with omega. So, this is omega and plus psi dot times C 3 cap, and then theta dot times d 2 cap we have got, and capital omega times F 1 cap we have got, and we need to differentiate this in order to get the d h by dt of the wheel with respect to E frame. So, this we will do with respect to first the F frame, in which the wheel moment of inertia it is not changing, and thereafter we can go up. Okay. So, here in this case I am discussing a case where your wheel speed, okay, this is the angular velocity of the wheel, this is also changing, and this particular part is called variable speed control moment gyros. This is variable speed CMG, okay, means you are changing also this, and this provides 3 degree of control. Okay. Earlier with if your this wheel you cannot speed up this wheel, say if omega dot is not present, omega dot is 0. So, only 2 controls, 2 axis control you are getting, one along the this axis which is the outer frame, and another you can get along this axis. Okay. If you restrain along this axis, you get output here, depending, if you are torquing along this, you will get output along this axis. If you torque along this, you will get output along this axis. So, you just have to look into where the resultant control moment will be. Okay. So, under this assumption, now we can, if we differentiate this, so we can write here I w outside, and then with respect to the F frame, and this is omega plus psi dot C 3 cap, theta dot d 2 cap, and capital omega times F 1 cap, and plus, so this quantity is your omega will with respect to the E frame. So, here this will come as omega will with respect to E frame and cross I will times omega will. This term we need to expand here. Okay. Thank you for listening. We will continue in the next lecture. Thank you very much.